In 1960, someone bought a Kelvinator refrigerator, and 66 years later, it still runs. In 2022, someone shared, "I have a brand new Samsung Smart Hub refrigerator. Now it's just a brick. The worst part is that it broke exactly 1 month after the warranty expired." The gap between those two stories is not just 50 years of technology. That is the gap between two philosophies. One is durable to endure, the other is sufficient to replace. In most advertisements, devices today are touted as being smarter and more energy efficient, but if you have to replace it every 5 to 7 years, is that really saving? We are sold convenience, but in return, there is dependence on the motherboard, firmware, and sealed components. Why are machines becoming smarter, but their lifespan is getting shorter? Why has repair become an unworthy option? Today, we will trace the rise and fall of consumer electronics to understand why your refrigerator is no longer built to last. Throughout the 3 decades after World War II, appliance companies did not sell features, they sold peace of mind that lasted for decades. And the feedback from customers is the clearest proof. Someone said, "I have a Kelvinator refrigerator from the 1960s, repainted, and it still works very well. The 30-year-old Speed Queen washing machine still runs strong. 1. It cools well. It cools well. It washes my clothes clean. It works efficiently." Others say, "My Kenmore clothes dryer from 1988 is still working very well. I have maintained it a few times over the years. I have always loved it." Compared to modern washing machines, the washing machines of the 1950s had no screens, no Wi-Fi, and no software updates, but it can run for 30, 40, even 50 years longer than a mortgage. Why can it last so long? Because its structure is like a miniature heavy-duty truck, detachable bearings. The engine is separate. A mechanical switch costs a few dollars. The entire rear assembly is opened with a screwdriver. If a component is faulty, you replace that specific component. Not replacing the entire ecosystem. Someone said, his Whirlpool washing machine from 1995 had the motor, drive coupling repaired, replaced once. The Whirlpool dryer from 1970 has also had its heating element replaced twice, but both still work well. It can be seen that, in this period, durability is marketing. The longer a product lasts, the more trusted the brand becomes. Reputation is passed down through neighbors, through generations, not through advertising algorithms. Not stopping there, most products of this era are equipped with thick steel, real gears, and simple technical logic. You can imagine their metal casing as thick as the body of a school locker. Inside are steel gears, belts, and a mechanical timer ticking steadily. No circuit board, no microprocessor, no plastic-sealed components. Each part is an independent block, like metal Lego bricks. If one part breaks, replace that part. If we compare it with a familiar image, a 1970 washing machine is like a Swiss mechanical watch. Many modern devices, on the other hand, are like a phone. When they malfunction, you replace the entire unit. The machines back then were designed to accompany a family for a lifetime. But then, what changed? When the market is saturated, most families already have refrigerators, washing machines, and ovens. If a machine lasts 30 years, revenue only comes once every 30 years. In the modern financial world, that is not an attractive growth model. Is the shift from durability to sufficiency to replace starting from here? Have you ever owned an old mechanical device that still runs well today? Share your story, because the next part will reveal how everything changed when electronic technology stepped into the kitchen. Around the early 2000s, a new wave swept into the home appliance industry. Full-scale electrification. Mechanical switches disappeared, replaced by circuit boards. The metal timer has been replaced with a microprocessor. Refrigerators are starting to have Wi-Fi, screens, and firmware. It sounds like inevitable progress, but in engineering, each new component is a new variable. If a mechanical machine resembles a simple steel bridge, then a smart device resembles a multi-layered subway system. Each layer works well, until a small sensor, a few dollar capacitor, or a faulty update brings the entire system to a halt. It is evident. The complexity of electronic products is increasing exponentially, and so is the number of potential failure points. The problem is not bad technology. The problem arises when technology is placed in an unforgiving environment. Heat, humidity, continuous vibrations 24/7. And that's just the beginning. For decades, rotary compressors operated like a small truck engine, spinning in an oil bath, self-lubricating, and durable. Then, the linear compressor appeared quieter, more energy efficient on paper. Instead of rotating, the piston moves linearly like a syringe. But when it no longer rotates, it no longer self-lubricates. It relies on a sophisticated system of valves and springs. Just one small part deteriorates, and friction starts to increase. When that happens, metal shavings can spread into the closed system like a grain of sand falling into a clock's gears. A component worth a few $100s can lead to the collapse of the entire cooling system. In the modern business model, is that risk calculated? Or is it just an acceptable cost? With the self-cleaning mode of the oven, it can reach nearly 900 degrees Fahrenheit, equivalent to heat strong enough to discolor metal. That heat doesn't just burn off the grease. It also affects the circuit board placed above. The repeated hot-cold cycle causes the solder joint to expand and contract, like a string being continuously stretched and released. Replacement circuit boards can cost several $100s, a figure that leads many people to choose to buy new ones instead of repairing. Users inadvertently activate features that reduce the lifespan of their own devices. So when smart becomes the standard, will strong be pushed to the sidelines? Are you willing to trade durability for features? Or have you ever experienced the moment when a modern device suddenly goes silent? Share your experience. And if you're interested in in-depth analyses of how business models are reshaping our kitchens, follow the channel so you don't miss the next part, where we delve into the bigger question: is a 5-year lifespan really just a coincidence? The concept of planned obsolescence is not new. It emerged in the 1930s and gradually became a popular business strategy after World War II. The idea is very simple and ruthless. When products last too long, the market becomes saturated. When the market saturates, growth slows down. During the period from 1940 to 1970, a family would buy a refrigerator that could last for 25-30 years. Imagine that as buying a car and driving it until your child grows up. But in the modern financial model, listed companies are not evaluated based on a 30-year durability. They are evaluated quarterly, according to annual growth, according to the upward trend. And here, the question begins to change. No longer how to make the most durable machine, but rather what lifespan is optimal for the revenue lifecycle. Simple comparison. In 1,971 machine for 30 years. In 2020, one machine every 5 to 7 years. In the same 30-year cycle, a family can buy 4-6 devices instead of one. If we were to draw an analogy, it's like moving from selling a lifetime home to selling a 5-year lease contract that repeats. Short replacement cycles generate steady, predictable cash flow. This pleases the capital market, where quarterly numbers are more important than generational durability. High durability reduces the frequency of buybacks. Low repurchase frequency reduces growth. And when growth becomes the guiding principle, product design also starts to pivot around that axis. So, what about repairs? In the old model, repair was a part of the product ecosystem. In the new model, repair is gradually becoming a difficult calculation. Integrated components instead of discrete ones. Sealed bearings in a plastic cage. The control board integrates multiple functions into a single unit. When a small component deteriorates, you don't replace that component, you replace the entire assembly. If a bearing costing a few $dozen leads to a bill of several $100s, the psychological calculation is clear. Buying new is more reasonable. It can be seen. It's not that the equipment can't be repaired, but the cost structure makes repairs hard to accept. This does not require extreme scenarios. Just need more integrated design, more optimized production, and naturally shorter product life cycles. So the bigger question is, are we living in a product economy or a subscription economy? Have you ever stood in front of a repair bill and felt pushed toward the decision to buy new? Share your experience, because in the next part, we will discuss the environmental paradox, when energy-saving products contribute to the ever-growing mountain of electronic waste. If you are interested in how finance, technology, and consumer behavior intertwine behind familiar devices, follow the channel to explore the deeper layers of this story. On paper, refrigerators today save significantly more electricity compared to the 1980s. Dishwashers use less water. The compressor operates more quietly. But let's take a closer look at the internal structure. To meet increasingly stringent energy standards, manufacturers must use smaller engines, optimize lighter materials, fine-tuning the system to operate close to the performance threshold. If we were to make an analogy, it's like a race car running at 95% capacity 24/7. It's efficient, but doesn't leave much room for error. The dishwasher used to complete a cycle in 45 minutes. Now it can take 3-4 hours to reduce the instantaneous power. The question to ask, is it really cost-effective if the device needs to be replaced after 5 to 7 years instead of 20 years? If you replace a refrigerator twice in 14 years, will the total energy for production, transportation, and installation be greater than the electricity you save each month? And that's just the tip of the iceberg. According to global estimates, the amount of electronic waste has reached tens of millions of tons each year, equivalent to the volume of thousands of high-rise buildings, and only a small portion is properly recycled. Each refrigerator is not just steel and plastic. It also includes copper, aluminum, circuit boards, refrigerants, hundreds of mixed components that are difficult to separate. When the life cycle shortens, the resource extraction cycle accelerates. Here is something to think about. A device that saves 10% electricity each year can become environmentally costly if its lifespan is halved. So, what are we optimizing? Monthly electricity costs or quarterly profits? What do you think? Would you prefer a device that uses a bit more electricity but lasts 25 years? Or a super energy efficient device that needs to be replaced every 6 years? In the next section, we will delve into modern refrigerators and how to make them break down faster than ever. Nowadays, many refrigerator models have Wi-Fi, remote control application, cloud synchronization, regular firmware updates. Sounds very modern. You can check the temperature via your phone, receive notifications when the door opens, and even see inside with the integrated camera. But hold on a moment. When a mechanical device starts connecting to the internet, it is no longer just a machine. It becomes a software device with accompanying hardware, and the software has a characteristic. It needs updates. Update to fix bugs. Update to patch security. Update to be compatible with the new ecosystem. When the firmware is no longer supported, the device is still there, but the experience may change. Like a phone after a few years, The hardware isn't broken, but the operating system is no longer optimal. In the modern business model, data is as valuable as physical products. The refrigerator can record door opening frequency, set temperature, operational error, usage time. At a minimum, it is technical data to improve the service. On a broader level, it helps businesses understand user behavior better. If we were to draw an analogy, each kitchen now resembles a small broadcasting point in the global consumer network. The thought-provoking question is whether you are buying a refrigerator or joining a service ecosystem, and then there is an increasingly clear similarity between refrigerators and smartphones, a 5 to 7 year upgrade cycle, dependent on software updates, application ecosystem. Monolithic design, difficult to intervene, a 1,970 refrigerator could run independently for 30 years. A smart refrigerator today can depend on servers, applications, and operating system versions. When software becomes central, the product's lifespan no longer depends solely on mechanics, but also on the support lifecycle. What do you think about household appliances becoming more like phones? Are you willing to trade durability for connectivity? In the next section, we will delve deeper into the ongoing debate, the right to repair, and whether consumers truly still own their devices. If you want to continue peeling back the layers behind familiar technology, follow the channel to accompany the next analyses. When repair costs approach the price of a new purchase, the initial frustration gradually turns into a bigger question. If I paid for the device, why can't I fix it the way I want? In Europe, new regulations are beginning to require manufacturers to provide spare parts for many years after they stop selling the product. Some standards require designs to allow disassembly with common tools, instead of completely sealed structures. Imagine this as requiring car manufacturers to sell spare parts for 10 years instead of just 2-3 years. It changes the entire supply chain and also the way businesses calculate profit life cycles. Outside of the large corporations, another network is emerging: independent repair shops, community sharing technical documents, forums guide self-repair. This is not a noisy movement. It's like an underground current. When the right to repair is restricted, the demand for autonomy increases. For many people, fixing a refrigerator is not just about saving a few $100s. It is a symbol of true ownership. If a $20 bearing can extend the lifespan by 10 years, why does the product structure make that more difficult? From the perspective of a modern MBA, the right to repair is not just an ethical issue. It is a dilemma between two models. Model A, revenue based on periodic replacement. Model B, revenue based on services, spare parts, and long-term reputation. Which model a business chooses will determine the structure of the product design. This debate is not just about refrigerators. It's about who controls the product lifecycle, the manufacturer or the user. What do you think? Should the right to repair be the default standard, or is integrated design an unavoidable aspect of modern technology? After all, what can consumers do in an ecosystem designed for a 5 to 7 year cycle? Here are practical solutions you shouldn't miss. First, choose simplicity over flashiness. In an electronics showroom, the model with the largest screen is often the most attractive. But the paradox lies here. Each additional feature is an additional risk point. No screen, no Wi-Fi, no ice maker integrated into the door. Sounds outdated. But technically, it's about reducing unnecessary complex layers. Imagine it like buying a car. A basic model with fewer electronic options might have fewer things to malfunction after 10 years. Fewer features don't mean less value, they mean less chance of breaking down. Secondly, keep the old machine if it still runs smoothly. A 1520-year-old mechanical device if still operating well, may be worth more than a new high-tech model. The mechanical structure is like a clockwork individual, components can be replaced. While modern monolithic designs sometimes require replacing an entire assembly for a small part, if your current refrigerator is still cooling steadily, sometimes upgrading is not the most economical decision. Third, calculate the total cost over 20 years, not just the initial purchase price. A $3,000 refrigerator used for 6 years costs about $500 per year. A $1,200 refrigerator used for 15 years costs only about $80 per year. When converted over time, the picture changes completely. Modern MBA calls this the total cost of ownership. Not just electricity costs, but also repairs, replacements, and risks. Question for you. When buying equipment, do you prioritize features or longevity? At the end, we will summarize the entire journey from the golden age of mechanics to the connected era. To answer the core question, is the 5-year cycle inevitable or just a design choice? From the thick steel machines that last half a century, to the smart devices that can be replaced in just a few years, this story is not just about technology. It is about design, philosophy, business models, and ownership. Is the 5-7-year cycle a natural consequence of progress, or is it the result of an optimal structure for short-term growth? We do not deny that modern devices are more energy efficient and more convenient. But the big question remains, do you want a multifunctional product or a product that has lasted many years? Have you ever owned a device that lasted more than 20 years? Have you ever faced a repair bill and chosen to buy new instead? Do you prioritize smart or strong? Share your perspective. Below real-life stories are the most valuable data. If you enjoy analyses at the intersection of technology, economics, and consumer behavior, follow the channel so you don't miss the upcoming topics. We will continue to explore how design decisions subtly affect the daily lives of each family. The content in the video is analytical and commentary-based, relying on research, public data, and market observations. The actual experience may vary depending on the brand, model, and usage conditions. Our goal is not to criticize any business, but to promote an open discussion about durability, the right to repair, and the future of consumer electronics. Thank you for watching until the end. See you in the next videos.